emissions have a completely different impact on global temperature. As soon as you start to reduce methane emissions, global temperatures follow them down, because methane has a short lifetime in the atmosphere, and you're propping up global temperatures as long as you're emitting it. But as soon as you stop emitting it or slow down the rate you're emitting it, global temperatures follow emissions down. So you can see in that right-hand panel, there's a completely different behavior between methane and carbon dioxide, the warming response to methane and carbon dioxide, as soon as methane emissions or either source of emissions starts to decline. And because we're looking at policies to reduce emissions, it's very important that we account for falling emissions properly. I'd like to stress this isn't sort of my pet theory. This is very well established science, and in fact there's a helpful sentence in the latest assessment of the Intergovernmental Panel on Climate Change. I wasn't an author on this, but I think this is a very good summary of where we're at, which is as follows: expressing methane emissions as carbon dioxide equivalent using the 100-year global warming potential. I haven't mentioned that yet, but that's just the conventional exchange rate we use to express methane as carbon dioxide equivalent. DEFRA or any carbon footprint calculator or farm calculator you might download off the web will use this exchange rate. This exchange rate overstates the effect of constant methane emissions on global surface temperature by a factor of 3 to 4, while understating the effect of any new methane emission source by a factor of 4 to 5 over the 20 years following the introduction of the new source. Now, that's a lot of information in one sentence, so we'll unpack it over the next few slides. But the first thing to notice here is these factors are not quibbling over 10 or 20% here. These are factors of 300 or 400% in terms of misrepresenting the impact of methane emissions on global temperatures. So this is, a serious misrepresentation, which I think is relatively easy to fix. And I'm now going to tell you how we can fix it. If you perhaps actually before I get on to how we fix it, is everybody pretty clear, sort of, based on these figures and so on what the problem is? Does anybody want to sort of chip in at this point with questions on or what that sentence means or what these diagrams are showing us?
No, the room's silent.
So I'm assuming silence is happiness as opposed to the silence of deep slumber. You never quite know talking to students, but I can't see you, but I'm assuming then that people are broadly happy. Okay, so I'll keep going and unpack what this means. Okay, so if you want to work out the actual impact of methane emissions, say the methane emissions of the Isle of Man on global temperature, so what the standard calculation, the one that DEFRA uses, is just you multiply your methane emissions by a factor of 28. That's the 100-year global warming potential number, and you say that's the carbon dioxide equivalent methane emissions. That's how you work out your carbon footprint. If you want to know your actual impact of your emissions on global temperature, you need to do something only slightly more complicated, which is you need to multiply last year's methane emissions by a factor of 128, so a much bigger number than 28, but then you need to subtract estimated methane emissions from 20 years ago multiplied by 120. Now, I spell this out because a lot of people like to sort of say, oh, what they're saying in Oxford's really complicated. It's far too complicated for policy. Let's keep doing what we've always done. Well, it's not that complicated. It's instead of one multiplication, it's two multiplications and a subtraction. Most of us know how to do that. And the point is that if you calculate your warming equivalent emissions in this way, then you can work out the aggregate warming impact of your emissions on global temperature. And it's simply proportional to your aggregate CO2 equivalent emissions, that's the standard multiplied by the standard factors of carbon dioxide. By the way, the factor for carbon dioxide, of course, is 1 because a ton of carbon dioxide is equivalent to a ton of carbon dioxide. And nitrous oxide, there the factor is more like 265 or so. Nitrous oxide is a very powerful greenhouse gas, but it also accumulates in the climate system, so it does behave like carbon dioxide. So it's a problem for the globe, our nitrous oxide emissions, but it's not a problem for our accounting systems because it behaves like carbon dioxide. So you can call 1 ton of nitrous oxide equivalent to 265 tons of carbon dioxide, and you get about the right answer. But if you want to know your warming impact, you have to add on your warming equivalent methane emissions using that little E star formula I show you above, which is where you multiply both your emissions this year by one number, your emissions from 20 years ago multiplied by a slightly smaller number, subtract them, and that gives you your warming impact. So let's look at the sort of implications of this. So if your emissions are unchanged, if you've maintained a constant herd, you haven't sort of changed your management practices or anything over the past 20 years, then you're only multiplying your emissions by 8. Yeah, 128 minus 120. And that means that your conventional carbon footprint, multiplying your methane emissions by 28, is going to be 3.5 times too high. Okay? Now, that's exactly the number which the Intergovernmental Panel on Climate Change mentions. Constant methane emissions are overstated their impact by the conventional carbon footprint by a factor of 3 to 4. So that 3.5 factor there is that factor of 3 to 4 in the Intergovernmental Panel on Climate Change's statement. Okay, so we've understood the first half of that sentence. If your emissions have risen in the past 20 years, then you have to multiply your new emissions, any increase that's occurred over the past 20 years, by that much bigger number, 128, because any increase causes lots of warming. And just to point out, 128 is roughly 4.5 times 28. So that's why the second half of the IPCC sentence comes about. It means that in the standard calculation, the standard carbon footprint using 100-year global warming potential understates the impact of any new methane emissions by a factor of 4 to 5. Hence that 4.5 factor that I'm showing you here. The IPCC includes some uncertainties in these factors. I'm just giving you the sort of central estimates. But the crucial point is, yes, there's some uncertainty in these factors, but we're talking about an uncertainty somewhere between 4 and 5. That's very different from 1. So the fact there's some uncertainty in the factors doesn't really give you a reason not to think about this process at all. Crucially, and this is where it gets really interesting when we're talking about falling emissions, and you might achieve falling emissions in all sorts of ways. I know that there's a lot of research going on about feed additives that could be given to ruminant livestock to reduce emissions, or feeding them seaweed apparently is one option. If you manage to get your emissions down by 6% over the past 20 years, and again, this just follows from the numbers in that formula, so that's 0.3% per year, or halving over 200 years, or however you want to put it, then your warming equivalent emissions of a livestock herd are net zero. So that herd is not causing any further global warming. It may have caused warming when it was built up more than 20 years ago, but it's not causing warming anymore. And that, of course, is not what's suggested by its conventional carbon footprint. And of course, if your emissions have fallen by more than 6% over the past 20 years, then they are having, these are the methane emissions specifically, they're having the same impact on global temperature as removing carbon dioxide. So negative CO2 warming equivalent emissions. So these are just the consequences of that very simple formula, which you can use if you can estimate what your emissions were 20 years ago and you know what they are now, then you can work out what the impact your farm or the Isle of Man as a whole, or whatever region you choose, the impact those methane emissions are having on global temperature. I must stress this logic, this formula applies to methane, because methane is what we call a short-lived climate pollutant. It has a lifetime much less than 20 years. It does not apply to nitrous oxide. Nitrous oxide is a long-lived pollutant, has a lifetime greater than 100 years. So nitrous oxide behaves like carbon dioxide. But since in agriculture, just to remind you here, if you look on the right-hand panel, emissions are dominated by methane and nitrous oxide, our decisions on how to manage these emissions are all about trade-offs between methane and nitrous oxide. And the difficulty we have is that these trade-offs are not being informed by knowledge of what our emissions are doing to global temperature, which is a bit odd, because after all, it's global warming that we're trying to do something about here. And so it would make more sense if our emissions, if the way we compared our emissions reflected their impact on global temperature. So if we focus in now on the warming impact that our emissions have had, and focusing on the right-hand panel here, I pointed out when I showed you this graph before that warming due to the UK's methane emissions has been declining since 2000. If you were to treat those methane emissions as carbon dioxide equivalent, so if you were to pretend they were a kind of carbon dioxide using the conventional 100-year global warming potential as an exchange rate, then you would think those methane emissions would still be causing global warming. The dashed line shows the warming that would be caused by carbon dioxide equivalent, in sort of notionally equivalent, to those methane emissions. And you can see the dashed line still going up, still causing warming, whereas the actual methane emissions are not causing warming anymore. So hence this is a discrepancy of not just, a few percent here or there, it's actually got the sign wrong, where I'm highlighting it in the arrow there. Just to sort of quickly check with the room, can people see why this comes about? Yeah, based on the fact that we're not when we treat methane as carbon dioxide equivalent, we're pretending, if you like, that it accumulates in the climate system, and therefore even falling methane emissions are still associated with rising temperatures, whereas in reality, methane does not accumulate in the climate system. So as soon as you start to bring methane emissions down, the temperatures, the warming they cause falls with them. So far, so good?
Yes.
Yep, thank you. Okay.